Hello everybody, welcome back. We're continuing with 7.6, vertex form of a quadratic function. Right now we're looking at example 3. It says give some reasoning about the number of zeros, so x-intercepts, right, that a quadratic function will have. Okay, so if we're given the function f of x is equal to 2 bracket x minus 2 all squared minus 5, you make a conjecture. My conjecture is going to be that there are 2 zeros. And why do I think that? Here's my reasoning. Well, first of all, the vertex, which is 2 and, negative 5, is below the x-axis, right? So it's 2 and down 5, and so it's below the x-axis. The vertex is below the x-axis. And the graph opens upwards because a greater than or equal to 0. Right, we have a 2. So therefore it's going to have to cross the x-axis in 2 locations. Let's graph it just to be sure. So when I graphed my equation, we were correct. Our vertex is indeed below the x-axis. Our a value is 2, which is greater than 0, therefore it opens upward. So we indeed do have 2 x-intercepts. Okay? So that is what is a conjecture, right? We say, okay, what's your conjecture? And then you give your reasoning. All right? And that's it. That's it. Okay? So I'm going to replace this graph here. And you can sketch that graph if you want as well. I just wanted to show that in my proof. Okay? And there we are. There's your graph. Okay? Let's look at the second one. Now this one here is an interesting graph. This is actually called what's called the base function, or the parent graph, which is kind of neat. Again, you don't have to know that, but I just wanted to share that. So what's the vertex here? Well, there's no vertex. Well, yes, there is, because it still takes on that form. And here it is. The a value is 1, actually. And if there's nothing here, you're still subtracting 0. And you're still adding 0. So it looks like, obviously, that there's no vertex. But technically, there actually is. Okay? I should have did that initially. I do apologize. All right. So we'll take this back to what it was. Just x squared. Okay. So I showed you there's actually a 1 here, and there's actually a subtract 0 plus 0. So therefore, my reasoning is going to be, so my conjecture is going to be 1, 0. I'll show you what. So since the vertex 0, 0 is at the origin, which is on the x and y axis, since it's on the x and y axis, there is only 1, 0 for x. Interesting. Okay, and if you're not sure of that, or what you don't understand that, and maybe I wasn't clear enough, all you do is graph it. Let's graph this equation. Oh, wrong one. Of course, you could do it there. So 1, 0, and plus 0. There it is. And again, I just want to show you that the original function was the same. If you want to take a look, equals x squared. Right? See how it overlapped? Right? So as soon as I put the squared in, it overlaps, right? It turns from red to blue. And that's because they're equivalent. And I just want to show you that as well. Okay? So there's your graph right there. And our conjecture was correct. And that was our reasoning. It wouldn't matter if it opened up or downward. You could mention that if you wish. It opens. You could mention that it opens downward or upward. Like, well, this one would actually open upward because of the a value being 1. But again, it's not necessary because, as I just showed, it's sitting on the axis. This is actually called what's called a touch. Okay, it comes down and touches the x-axis in at one location. Okay, but that's all you need to explain is because the vertex is right on the x and y axis here, right? If it was slid over here, it was just on, let's say, the x-axis at 5. Okay, I can show you the graph of that as well. If this x value is 5, it's over here, so it's still only 1, right? So as long as as long as the y value of the vertex is 0, essentially, that will hold true. Okay. Well, for that specific graph, that was what the conjecture came from. So my conjecture here is, well, we got a vertex is at -3 and +4, so it's going to be up here somewhere, and it opens upward. So I'm going to say there's going to be no x-intercepts. Or no zeros, I guess I should say, right? No zeros, or, again, intercepts, all right? And my reasoning is, okay, I'm going to steal this for a minute. So the vertex is at -3, -3 and 4 from our graph, right? So whatever this sign is, it's the opposite in the vertex. And then just take whatever in front of to the left of 4. And that is above the x-axis, right? It's going to be right here. And the graph opens upward, so there's not going to be any, right? So there is no zeros. Okay? Again, a visual may help you see that. So I'll take this and I'll plug it into Desmos for us. Great program. Exit the last two graphs, plug it into Desmos. And there it is. Our vertex is at 3 and 4. It opens upward because our a value is greater than 0. Therefore, indeed, there are no zeros or x-intercepts. Okay? Get rid of that graph. We can replace it with ours. And there we are. And that is it. Okay? For that question, example 3. All right, last one, example 4. Solving a problem that can be modeled by a quadratic function. A soccer ball is kicked from the ground after 2 seconds. So if that's time, so that'll be your x-axis, your x value of the vertex. The ball reaches a maximum height of 20, and it lands on the ground at 4 seconds. Determine the quadratic function that models the height of this ball. So sometimes a visual is good here. So what we're going to do is we're going to draw a visual. So it says it's kicked from the ground. So the ground means it would start at 0 and 0. So we're going to plot that point. There we are. 0, 0, that's where it starts. Then it says after 2 seconds, it reaches a maximum height of 20. So that point right there, it's going to be at 2 and 20. Label that. And then it says after 4 seconds, it reaches the ground. So it's back to 0 for height. So this would be at 4 and 0. There's a point there. And of course, I'm going to label it. All right. And there's our graph, which is kind of neat. So that's a visual. And then you would draw the curve through. So we draw our line through 0, 0 up to 220 and back to 4, 0. And then remember, we don't have to go underneath the the x-axis, and we don't have to go over to the left of the negative x because the time's negative and it's stopped. So that will help you with domain and range if you have to do domain and range. So I'm going to take a quick picture of this for our notes. And that would be what you would want to draw as some sort of sketch. Now, it doesn't have to be perfect like the graph I had. I just did that because I had the computer there to help me with that. But all you need to do is a little sketch like that. So what I would do is, and I'll show you in class, I would just draw a quick sketch of this. It doesn't have to be on a graph paper. You could if you want, but not necessary. So there's a number of ways you can approach this question. We're obviously going to do a vertex form because that's what we're in. But if we were given this question, we could solve it any way we want, but we're going to do it in vertex form. So we know that the vertex is 2 and 20. You can see that from the diagram, 2 and 20. And remember, that represents h and k, right? So So that represents H and K. That's important that we understand that. So that represents H and K, like we talked about at the beginning. So that can go into your formula. H is 2, K is 20. Oh, I'll rewrite that so you can see it for the notes online. So that is 2, and that is 20. All right. So now we need to pick any other point, right? So now we have to solve for A. Oh. So when we solve for A, the ball lands on the ground of 4 and 0, so we can use that, and we can take this to represent our X and Y, because X and Y can be any other point on the graph. Okay, so we'll take their equation. We've already entered the vertex in. Now what we're going to do is we're going to put in the X value at 4 and the Y value. Oh, I'll do that. I'll rewrite that. My apologies. X value, just like we did in the last question, at 4, or sorry, example 2, and our Y value at 0. Substitute those values in, solve for A. So 4 subtract 2 is 2. 2 squared is 4, so it gives us 4A. Subtract 20 from both sides, so the 20's gone, leaves you with negative 20 over here, right? Divide both sides by 4. Oh. Divide both sides by 4. Divide that by 4. Divide this by 4. The 4's are gone, right? 4 divided by 4 leaves us with A, and then ends up with negative 5, right? So that tells us that our function is going to be, just grab your vertex form of the equation. Remember, we just found A was negative 5, H is 2, and K is 20. Okay? We need X and Y in our equation to have our equation. So that is the equation in vertex form. And you want to put it, and that's good. And then the B part says, so remember our graph, and we talked about earlier, the X values go from 0 to 4 and they stop, right? Because that's time. So where it starts, at its highest point, and when it stops, after 4 seconds. So that X value, 0 less than or X less than 4. And again, you can have that interval notation, or you can say square bracket 0, comma 4, square bracket. But remember, that's not a coordinate. That is interval notation. It's important to remember that. Same for the Y. Y starts at 0, goes high as 20. So we can say that is 0 less than Y less than 20. Or we can say that that is from 0 to 20. Okay? So either one is okay for that representation. All right? So the last question says, what will the height of the ball be at 1 second, and when does the ball have the same height on the way down? So it's going to have that same height. So we're going to look at your graph. So we're going to go to Desmos. I'm going to graph that for you. So at 1, you can see it's 15. So it's 1 comma 15. That's how you do a graph. Oh, comma 15. That's how you do it graphically. I'm going to show you how to do it algebraically as well. All right. And on the way down, the same height would be at 3. So I'm going to label that for our graph, and it would also be at 3 seconds. Because on the way down, right? So on the way up, at 1 second, it's at 15. And then on the way down, at 3 seconds, it's also at 15. Okay? And there's your graph to show that. So that's how you would show it graphically. Okay? So that's graphically, but algebraically, here's what it's going to look like. So graphically, what we would do is we would let x equal 1, because it's set at 1 second, right? Time is on the x-axis, so anywhere we see x, we put in a 1. Okay? And we solve this for y very quickly. 1 subtract 2 is negative 1. Negative 1 squared is 1. Oh, bracket, sorry. Negative 5 times 1 is negative 5, and negative 5 plus 20 is 15. And again, you can see the graph using symmetry to get the other value for 3. Algebraically, we'll see that again another time. But these are the questions from page 4, 17, 1 through 5, 7, 11, 12, 14, 15, and 18. Hope the videos are helping, and we'll talk again soon. Thank you.